So we're starting our first warm-up. This warm-up is a review of the different things in our lesson we've done so far to help lead us up to what we are doing today. Who'd like to walk me through the first one? Daniel.
You have to turn the 2 into a fraction.
Exactly, we turn the 2 into a fraction. How do we do that?
You put it over 1.
Exactly, and why do we know we put it over 1, you guys? Who can tell me why we know we put it over 1? Hannah.
Because it's a whole number.
Exactly, it's an integer, as we know, and every number can be a fraction, even whole numbers, if you just put them over 1. Doesn't change anything, right? So we have to make it into a fraction. And then what do? What's the next step? Liam.
We multiply it by 1/3.
Perfect. We multiply it by 1/3. And I want you guys to do this as a class. Show me your fingers. Ready? What's 2 times 1? Excellent. We know that. What's 1 times 3? So is this our answer? Yes. Excellent. Easy peasy for that one, right? Now this one gets a little bit more complicated. We've gone over this one. This one was one of our closer past lessons. So what's the first step that we do, Lucy?
Well, first, you know that you have to keep 3/4 the same.
We keep 3/4 the same. Then what do we do?
And then you change the division symbol to multiplication.
Excellent.
And since you're doing multiplication now, you have to flip the 9/8 to 8/9.
Perfect. And what's that called when we flip that?
Reciprocal.
The reciprocal. Exactly. Now, I asked you guys this before, and I'm drilling it in because we want to see this is important. Now, what's my way that we remember reciprocal? What do? How do we do it, Miles? Reciprocal, because we're flipping the fraction. But what does a reciprocal mean? Like when we're doing that, what numbers are we flipping? Like how are we flipping it? We're flipping 2 math terms. I want to see somebody. Let's see. Elsie.
The denominator and numerator?
Yeah, we're flipping the denominator and the numerator. Excellent. And what's the relationship between the reciprocal and the original term? What happened? Like, what's the relationship between the two of them? What do we know? I wish I had more students in my class. I love my 3 students I have, but I wish I had more. Let's see. What is it, Rocco?
Like instead, because before 9/8 it was like improper?
It was improper, yes, but we can deal with improper fractions. That still works. Yes?
It's the same number, it's just their...
Same number flipped, yes. Does anybody else have any idea? Remember what we said? The correlation between the original and the other one is. So we have 9/8 and then we have 8/9, right? What's the correlation? What happens between these two numbers when I do something? Remember, Jenna?
It equals to 1.
Exactly. When does it equal to 1? When we add them?
No, when we multiply.
Exactly. When we multiply, it goes back to 1. So we can always check. There's 2 ways, the reciprocal or the refliprocal, just by flipping. And we check based on if we multiply our fractions, which we're good at, to see if we get back to 1. So I'm going to call on some people. Now, I can just multiply these across easily, right? But I could do something else first. Who remembers what I could do first? Let's see, Lily. Cross canceling, exactly. Madison, you had your hand up, nice. What can I cross cancel in this equation?
3 and 9.
Perfect. 3 and 9 first. So, what does the 3 and the 9 become? What do they become? Who can tell me? Michelle.
The 3 becomes a 1,
Yes.
and the 9 becomes a 3.
Excellent. And Oleg, why? It's okay. Take a guess. Okay, let's see. Romario, do you want to help him out?
Yeah.
Why did the 3 become a 1 and the 9 become a 3 when we cross-canceled?
Because you're basically dividing the same number by, just like LCM.
Yeah, the GCF. Exactly. Great job. We were dividing them by the greatest common factor. And the greatest common factor happened to be 3. So, is that all we can do? We're done? No? What else can I do? What can I do, Fernando? 4 and the 8. So, Oleg, what's the greatest common factor between 4 and 8?
4.
Exactly. So if we divide them both by 4. What's 4 divided by 4? Fingers up. Easy. What is 8 divided by 4? Fingers up. 2. Exactly. Super easy. Hey, look at what answer do we get here? Who can tell me, Daniel?
2.
Perfect. 2/3. Exactly. We get 2/3, which is fun because we get to see how different numbers still produce different things. Yes.
Oh, sorry, I was going to...
Oh, you were going to do the next one? Okay, perfect. So has everyone had a chance to work on this last one with mixed numbers? Awesome. Okay, So this was an introduction. We did this lesson, I believe, last night when we were working on this. So everybody should have had good exposure. Now, I looked at some of your homework and I saw that there was some misunderstanding. So I want you guys to watch. What is the first step that we do, Lucy?
You have to change the mixed number to improper fraction.
We have to change it to an improper fraction. And why do we have to change it? What can't we do? What can't we do, Hannah?
Because it's a lot harder and you probably can't do it.
Yeah.
Because you can't multiply a fraction by a whole number and a fraction.
Exactly. Whenever we're doing it, just like in that first one, when we turned that original whole number into a fraction, we have to keep everything as fractions. So raise your hand. What is 1 1/8 as a mixed number, Michelle?
9/8.
Yes, 9/8. And once again, how did you do that?
So you do the whole number times the denominator.
Whole number times the denominator. We say what? Multiply by, remember? Excellent. And then what?
And then you add the numerator.
So then we add the numerator. We put it back up to the top and we add it. And what happens to that denominator? Does it go away? Does it change? What happens to that denominator? Malia? Stays the same. We always keep our denominators no matter what. So 1 times 8 is 8 plus 1 is 9. That's what we get. Now, we still have another step. Can I just do this? Divide by 3/4? I'm done when I'm doing that? No. What do I do, Elsie?
You change the division side into multiplication.
Perfect. And then what's the next step? Somebody else? I want it, Fernando.
You flip the fraction.
Excellent. What's that called again?
Reciprocal.
Yeah, we're finding the reciprocal. So what is the reciprocal of 3/4? I want everyone to say it out loud at the same time. Ready? 3, 2, 1.
Quarters.
Excellent. I'm glad everybody knows it. It's fun, right? The reciprocal or reciprocal. Exactly. Now, in fact, it's pretty much the same cross-canceling as last time, which, okay, took it from the book. Now, once again, we see this. The 9 and the 3 right above, it becomes our 3 and 1. Our 8 and 4 become a 1 and 2, right? Everybody, same exact one as the one right above it. Now, what do we get as our answer? Who can tell me our answer, Daniel?
1 1/2 as a.
Yes. So we would get 3/2, as you said, just by multiplying across, right? But you already went a step ahead, and you made it back into a mixed number, and you got 1 1/2. Exactly. How'd you make it into a mixed number? So we had 3/2. How do we make it into a mixed number? I want someone other than the person who just told me how to do it. Let's see, Rafi.
You simplify 3 to 2.
Exactly. How do we simplify it? What? Mm-hmm.
You take the denominator and you can see if it fits inside 3 or denominator.
Excellent. Yes. How many times does the denominator fit inside our numerator, Hannah?
It fits inside 1 time.
It fits inside 1 time. So we had that 3 minus 2 over 2. We got that. And what did we get there? What did we get there? Rocco.
1 1/3. Wait, no,
1 and
1/2.
we got 1/2, which brings that up here. So these two numbers are the same. You guys are pretty good at converting these. So exactly, we got 3/2, but then we make it into our mixed number form, 1 and 1/2. How do we tell the difference between a mixed number and an improper fraction again, you guys? How do we tell the difference? And not just because I don't want to hear they look different. What is how do we tell? Let's see. First, Miles.
The mixed number 2 of how do you tell the difference?
Yeah, what is the difference? Like, how do we see the difference? What is the visualization of the difference? Lucy?
A mixed number will always have a whole number.
A mixed number will have a whole number in it, yes. Would you have anything else to add?
I was going to say the mixed number has a whole number, and usually on an improper fraction,
Mm-hmm.
the numerator is greater than the denominator.
Exactly. Our numerator is greater than the denominator. And the reason we call it an improper fraction, we've gone over this, but whenever mathematicians get to fractions, we tend to love pizza because that's really helpful for us. So in this case, I split my pizza into 2 parts. Or I split my pizza into 2. Let's do it like this. I have 2 wholes, and I split them into 3 total parts. But it doesn't necessarily work as well because of the way it is. We have to split them into 1 and 1/2. It's a whole thing. So when the top is bigger, when our numerator is bigger than our denominator, it doesn't work because can the part be bigger than the whole? No, that's not how we express it. Part is not bigger than whole. Which one's part in this equation? Which number is the part? Which number? Elsie. The numerator, yeah, which is 3. Exactly. So then, based on Elsie's answer, who can tell me which part is the whole? Let's see, a new hand. Lily? The denominator, exactly. So, let's see. We're going to look at this next warm-up, and we're going to do it together a little bit. I want you guys to start individually. I'm not writing warm-up because it won't show up, apparently. Let's see. Yeah, you can't see it very well. So, we're reading this. The deepest point in the Earth's oceans is the Mariana Trench, which is located 6 4/5 miles beneath the ocean surface. So as we know, we've gotten to our period. What does that mean when we get to the end of a sentence, Rocco?
It's like one piece of information.
Exactly, it's one piece of information. And who can tell me what that piece of information we had from this sentence was? Let's see, I want more hands. Who can tell me what that piece of information was, Carmen?
How many miles it's located from Mariana Trench?
Exactly, the how many miles it's located. And it's 6 4/5 miles. What other word do we see in this equation that tells us what we're going to be doing? Elsie? Beneath. Exactly, we see it's beneath the ocean. The next one. The average depth of the Earth's oceans is 2 1/2 miles. We have once again reached what? What have we reached again? What are we? Oh, wait, yes, you said it, but we want to raise our hands. Yes, we reached the end of our sentence, Daniel. So now we have another piece of information. What's our piece of information here? Yes, Jaden.
It's telling us the average depth.
Yeah, it's the average ocean's depth, so that's 2 1/2. Reading our last sentence. By contrast, the highest elevation of Earth is Mount Everest, which is about 5 1/2 miles high. As we know, what's the piece of information here? Who can tell me? I want to see some new hands. I want to see Tobias. Exactly. It's the height, 5 1/2 miles. Whenever we're reading problems, we like to break it down sentence by sentence because, as you saw, each individual sentence had its data. So, first things first, we want to write an expression. What kind of expression do you think we're going to be writing? A multiplication expression or a division expression? What kind of expression do you think? Do you think, Fernando? What do you think? Probably division, right? That makes a lot of sense because what are we trying to do? We're trying to find something, and we know this keyword. We're trying to find the what between two things. Elsie?
Average?
Not the average, but that's great. I love that. Yes, Anita?
Difference?
The difference between two things. And we're finding the difference. That means subtraction or that means division when we're looking for the difference. So we're looking for the difference. And Fernando was right. We write a division expression to find out how many times as deep the Mariana Trench is than the average depth of the ocean. So here we've got our Mariana Trench and we write it out. We know it. What is the Mariana Trench's information? How deep is the Mariana Trench? Rocco? 6 4/5. Excellent. So I want you guys, you should be writing stuff like this down. Just not all the word problems, obviously, as we've done before, but because this is also in your book, but I want you guys to write the expressions down so that we can look back at it later. Then we are dividing, just like Fernando said, and we are dividing by the average ocean depth. What's the average ocean depth, Lucy? 2 1/2 miles. Excellent. Are we done? No, we can't do it like that still. We still can't do it like that. Why can we not do it like this? Why can we not just go ahead? I see a lot of hands. I'm so happy, Romario. Exactly. We want to change our mixed numbers into improper fractions. I'm covering this up so that we have enough space to work. So, first things first. 6 5/4. So we multiply our big number, our integer, by the denominator, and then add it to the numerator and keep our denominator. That's what we said earlier. So I want to see who can tell me what is 6 4/5 as an improper fraction. Liam? 34/5. Excellent. 6 times 5 is 30, plus 4 is 34, and we keep our denominator. And we're dividing it. Now, what is, Daniel, 2 1/2 as an improper fraction?
5 halves.
Is it 5 halves? Do we agree? Thumbs up if we agree. Yes, we agree. It's 5 halves. By the way, notice now, because they were mixed numbers, both of our numerators are bigger because they turn into improper fractions. So if you're doing this on your homework and you come up with something that the numerator ends up being smaller when you're doing a mixed number to an improper fraction, what do you know about that? Yeah, what is it, Miles?
It's wrong.
It's wrong, exactly. That's a good way that we can go about checking. So when we're doing this, what is the next step in our problem solving thing? And I want to remember the key phrase that I used yesterday. Remember our Kentucky chicken fried? As we did that, Hannah, what do we do?
You have to rewrite it.
We're going to rewrite it. Yes. Let me see. Hold on.
Then you
30.
You multiply, but you have to use the reciprocal.
We use our reciprocal. What's the proper term?
Reciprocal.
Excellent. We use our reciprocal. I like saying it, though, because it really helps me remember, too. So, what's the Kentucky chicken fried that we talked about? I know it sounds so silly because I couldn't come up with anything better. Yes, Lucy.
Well, you keep 34 fifths, and then you change the division symbol with multiplication, and then you flip 5 halves to its reciprocal.
Perfect. What is that last one? Keep, change, flip? Exactly. So we keep, we change, we flip. Kentucky chicken fried. I wish it was KFC, but it's not. So, excellent. Great. We go about this. Can I cross cancel anything? Let's see. Raise your hand. Can I cross cancel anything, Fernando?
Yes.
What can I cross cancel then? So I'm going to cross cancel these 5s and 5s and turn them into 1s, right? Can I do that, Elsie?
No, you can't.
Why can't I? They're both 5s.
Because when you cross cancel, you can only cross cancel diagonally.
Yes. What would, if I'm doing this, I call it the what? What do I say when we're doing it like that, Miles?
Cancel?
No, I don't say it like that. What do I say, Anita? Across cancel. And can we across cancel? No, we can't across cancel. So Anita and Elsie are right. We can only cancel on the diagonals. So once again, is there anything that we can cross cancel? No, we can't. So we just have to multiply. 34 times 2. If you don't know this, it's easy to break up into pieces. So I want to do this. We've done this before in your earlier classes. We do 30 times 2 and then add 4 times 2. That's an easy way to remember it if you don't know how to do it. We break it up just like in math. We split it into 30 and into 4. 34 is split. This is times 2, and then this is times 2. So, what's 30 times 2? Romario. 60. Easy. What is 4 times 2? Matthew. 8. So our answer that we get at the top is going to be 68, right? Yes, it is. We want to hear yes, our chorus of yes. And then the bottom. I hope everybody knows this. What's 5 times 5? Let's see. Well, I want everyone to say it. Ready? 3, 2, 1.
25.
Excellent. I didn't hear a single different answer there, so that makes me super happy. Awesome. I'm done, right? No, but that, look, there was nothing to cross cancel. There was nothing to do. What? I'm not done yet? Oh my goodness. What do I have to do, Liam? I have to simplify. So, just by our knowledge, 25s are my favorite because I like to think of money, right? We all know about money. So, how many 25s fit into 68? Just by our money signs. Rafi?
2.
2 of them. Because we think 2 quarters is 50 cents. What's 3 quarters?
7.
We're raising our hands. Yes, Romario? 75 cents. Too big. So, we take 50 away from which number? What are we going to take 50 away from, Hannah?
You take 50 away from the numerator, which is 68.
Excellent. And what happens when we take 50 away there? What do we get? I want to see, what do we get, Michelle? 18. So I'm going to get 218, right? Put the 18 there?
Oh.
No. What do I get then, Lily?
You get 2 and 18 over 25.
18 over 25. We always keep the... Yes, we always keep the denominator. So both of these answers are correct. But which answer is better than the other answer? Which answer is better, Michelle? The 2 and 18 25ths. Exactly. The 2 and 18 25ths. Now, we're still not done with this problem. So far, we've solved one part of it. We've solved the difference between the marina trench and the average ocean depth. So we found out, as I'm using my pen wrong, that the average distance is 2 and 18 25th miles, because it said miles in the problem. Not you, Miles. Start calling you kilometers when we get to that lesson.
No,
So, what do we need to do now? It's asking us for the other one. We're talking about Mount Everest. Everest! So now what do we have to do? What are we going to do here? What kind of expression? We already said this last time. What kind of expression, Anita? Division expression. Exactly. We know this because we were following our earlier one. And once again, we're trying to find the difference. Exactly. So, we saw it on the first page. I'm not going to go back. We know our average ocean depth was 2.5. And then who had it written down? What was Mount Everest's? Who had it? Michelle? I think it was 5.5 too. I didn't want to look back though. So 5.5. Excellent. Now, once again, we got to make those into what? Rafi? Why do we make these into improper fractions? Can't I just multiply? It just seems so much easier that way. Oh, come on, Lucy. Yeah, we can't do it. Some of the mistakes that I've been seeing people make on this, we had 5 1/2 and divided by 2 1/2. If we just pretended for a second that it was a multiplication problem, just pretend that this is multiplication right now. Some of the things that I've been seeing where they multiplied the integers and then they just multiplied across and got stuff like that. Is that correct? No, you can't multiply things separately. All of them are part of the same numbers. They're part of the same numbers. So, when we turn this into an improper fraction, who would like to tell me the first improper fraction, Fernando? 11 over 2. Exactly when we followed through. Ben, what's the second one? 5 over 2. Awesome, I just multiply these together, right? What do we think? Madison, I just multiply them? Don't be making noises. You're not Madison. So am I done? I just multiply these two, the 11 over 2 and 5 over 2?
No.
Why don't we then, Madison? Do you want to call on a student for support? Call on a student for support. Shh. Yeah, we have to do certain things. This is still our division sign. If we want to do multiplication, we got to do the reciprocal. What's the reciprocal of 5 halves, Hannah? 2 fifths. 2 fifths. And what's great is that kind of got us back to a proper fraction, but it's not going to stay too long. Awesome. I'm just going to move on, right? No, what do we do, Madison?
Now we're going to cross cancel.
Cross cancel. What do we cross cancel? What do we do, Michelle?
You cross cancel
The 2's. What do the 2's become? 1. Their greatest common factor is 2. So when we divide them both by 2, we get 1. What about the 11 and 5?
No.
Can I do that?
No.
No? Yeah, exactly. They don't share a common factor. Does 11 even have any factors besides 1 in itself? No. So what does that mean 11 is? What does it mean it is, Hannah? It's prime number. 5 is also a prime number too, but since it's the smaller number, it might fit into a bigger number. So if it said 25 up there, but that's such a great question. He pointed out it's prime. So yeah, it is possible to work with prime numbers in these cases as long as the prime numbers are the smaller ones, because they would be serving as what? They would be serving as what part in our GCF? Are they serving as the greatest common of what? Hannah? Yeah, they're serving as the factor part of it. They might be the greatest common factor. Exactly. So we cross those out. Now we do our multiplication, right? I'm not tricking you.
Okay,
Yeah, I'm not tricking you. I know, I've been tricking you. But 11 times 1 is?
11.
1 times 5 is?
5.
Awesome. There's my answer. No, we're not done yet. What do I do, Rocco? Simplify. How do I do it, Jaden? You were so eager, I want to call on you. 2. 2 and what? 2 and 1/5, exactly. And that's called a, Rocco? Mixed number. We did that one earlier. He found how many times 5 went into 11 without going over. It goes in twice. It's a good one. We know it goes to 10. We subtract that from what? We subtract the 10 from what? From 11, from the what? Anita? From the numerator, and we keep the denominator. Exactly. It's exactly the reverse steps of making it into a mixed number. when we make it into a mixed number, I like to draw my spiral. I keep going on that pen. We like to draw our spiral that way where we multiply and then add. But in this case, what we're kind of doing is we're doing division and then subtraction in that order. So it's kind of reversed. Now, that's how we found our answers. That didn't help. Okay, hold on. Why did it go over that? Okay, we're going to do this. So, did we get our answer? Yes, we did. So we found out that it is, although here we write it as a mixed number and improper fraction. We already did this because we went ahead. So we found out that our answer was 2 1/5. Exactly. Now, I want you guys to tell me this. Here are the steps. I'm just going to write steps for this one because it's not technically first steps. So now, when we're dividing our mixed numbers, we've already said the steps, all of this in class. So let's go over the steps. What's the first step when dividing mixed numbers? The very first step, Miles.
Make the mixed number an improper fraction.
Perfect. Make mixed into improper. Keep this in your notes, okay? Making sure you keep this in your notes because otherwise you're not going to do so well on the test. What's our second step when dividing numbers? What's our second step, Lucy?
Well, after you make it into an improper fraction, you just divide it and well, I don't know how to say it without saying the whole thing.
I know. It's basically the whole thing that we're doing. So just say the phrase that we do. Exactly. We're going to keep, change, flip. Exactly. And then when we keep, change, flip, now what do we do? Miles, put your hand down. I'm not calling on you right now. You already know all of the steps. I want someone else. I'll call on you for the next answers and stuff. So what are we saying? When we do the keep, change, flip, I don't have an example necessarily on the board, but we'll go over an example next. Romario, then what do we do?
Then you look at, like, if you could cross cancel.
Yeah, we see, can we cross cancel? Can we do that? Yes, like we look for it. The question mark means, is it possible to cross cancel? If it's not, if it is, then what do we do after that, Daniel? We multiply to solve. Multiply to solve. Am I done? No. What's the last step with the mixed numbers, Rocco?
Simplify.
Yeah, I don't have much room, but we simplify into what? What do we simplify into what, Rock? Yeah, into mixed. So it's a lot of steps for this. We have 5 steps. However, sometimes cross cancel comes into play. So I don't know why that happened. So we're going to do this. Open your books to page 326, 327. And we're going to be working on those ones in the bottom. I want you to pick 3 from those problems. And I'm going to be coming around and offering assistance to those who are having trouble with them. If you are not having trouble with them, I want you to at least do D and F. If you are not having trouble, I want you to at least pick D and F. If you are having trouble, then we will get to those. But if you are not having trouble, I want you to pick D and F and any other one of your choice. Yes.
Okay, so F and KCF, is that for like reciprocal?
I didn't understand your question.
So in the second step, keep, change, flip.
Keep, change, flip, yeah.
And that reciprocal.
Yeah, exactly, which is why I called it that. The flip is like our refliprical for the reciprocal. Exactly. So do those, and I'm going to come around and offer a system. So Lucy brought up a great question. She was really unsure if it worked. And here's the thing. She knows what she's doing really well. She practices this a lot. And even she was unsure. So she had 4 1/5. This is D, so make sure you look at D. Divided by 2 1/3. When she did this, I'm just going to speed through the beginning process because I want to show you what the real point of why I'm bringing this up is. So we had 4 times 5. We get 20. Add it to the numerator. We have that. Or 4 multiplied by, as I'm saying that. So we get 21/5. Everybody agree so far? Yeah, we all agree so far. Then we're going to change just in our way because it's easy. We'll just make this one into an improper first. What is this one as an improper fraction? Ben, what is 2 1/3 as an improper fraction?
7/3.
Perfect. We get 7/3. So now that's what we're working with. Awesome. So we do our keep. That's the same. We do our change. That becomes multiplication. And we do our flip. So now what we get is, I'm going to make another slide, 21/5 times, and then what's the what do we do here? What is the keyword we're looking for? And what is the answer? Give me the keyword and the answer, Fernando. Which is called the? Excellent. The reciprocal or reciprocal. And what's the reciprocal of 7 over 3? 3/7. 3/7. Now, for those of you who are struggling with our greatest common factors or having problem with dividing, you can multiply it first and then try to do it. But I highly advise cross-canceling. So, what can we cross-cancel in this problem? Oswaldo.
21 and 7.
21 and 7, right? They share a factor. What's their greatest common factor?
21 turns into 3 and 7 turns into 1.
Why? So that means which number is their greatest common factor, Hannah? It's what?
3.
That's their greatest common factor. Yes, I know you guys always say that. I always say that too. So because we get 3 as our answer. So it becomes a 1. We're dividing them both. And this becomes a 3. Awesome. Now I'm going to cross cancel out these two and make it super easy on my life, right? So we get, right? No, I can't cross cancel. So we're left with 3/5 times 3/7, right?
Wait. No, it's 3 over 1.
Oh, 3/1. Thank you for catching me. See, even I make mistakes. I was looking at that and I was like, that doesn't look right. So 3 times 3 is?
9.
5 times 1 is?
5.
We make this into a mixed number. How many times does 5 go into 9 without going over? Fingers up. How many times does it go in without going over? 5 goes into 9 4 times?
1 time.
1 time. So it becomes 1. And what's left over? That's what your answer was. What was left over, Elsie? 4/5. Awesome. Now, Lucy was worried that didn't look right. She was saying 1 and 4/5, that doesn't look right. But let's use some estimation here. Let's just look at our big numbers. We have 4 divided by 2. What's 4 divided by 2? Rocco? 2. Isn't this number really close to 2? Yeah. So that tells us with our estimation, like earlier in our unit, that we know our answer is going to be relevant. Had we gotten something like 7 and 3/8, does that make sense when we're dividing 4 by 2? No, does not make sense. So, I was going to go over these, but we went over some of them, and we'll look at some of them if we have time afterwards. But what I want you to do first is we're going to go to the guided practice page. You get to pick 2 of them from 1, 2, and 3, and 1 of them from 4 and 5 to get us an example. I want those who are a little bit struggling to start with the 4 or 5 so we can work on reading our word problems. Ben brought up a really good problem that I want to bring up. He was saying this whole 3 and 3/4 divided by 5 and 5/8. Not to put you on the spot, but what was the answer that you got?
I got 15 over 4.
You got 15 over 4. Now, 3 divided by 5, if we just looked at it and did our estimation, that's actually almost 4 and actually almost 6, but it doesn't matter regardless. Anything. 3 divided by 5. Are we going to be getting a number bigger than 1 or smaller than 1? What are we getting, Rocco? Smaller than 1. So we use our estimation techniques to know that our answer is going to be smaller, right?
What number is this?
That was just an example that was given. That was just an example. But thank you for trying to check. Real world example from me. Miss Diaz wanted to cut a 6.5 foot rope into 3, and that's supposed to be a 1, 3 1/4 long pieces. Write the expression. So first, who could tell me just the initial expression? What would that initial expression be, Fernando?
10 1/2 divided by 3 and
It's supposed to be a 1.
3 and 1/4.
Excellent. So it's going to be 6.5 divided by 3 1/4. How did we know it's division? How did we know it's going to be division? Lucy?
Because you're something is a big piece, so breaking it up.
Exactly. We're breaking it up. We're breaking it up into even pieces. It's repeated subtraction, which is called division. Just like repeated addition is called multiplication. Exactly. So if you're done and you're in that group, I want you to solve this. And when you're done, remember, give a thumbs up. Find someone else with a thumbs up and work together to come up with at least 1, preferably 2 real-world examples. These real-world examples should include 2 mixed numbers. 2 mixed numbers. So try your best. It might be something like baking. It might be something like other things. So we'll see. Lucy, what was your real-world example?
This one is like the just like baking,
So someone has 3½ cups of baking mix, you said? And then what?
They're evenly into 8 bowls.
Evenly into 8 bowls, right? Exactly. That's great. That's great. I want some with 2 different mixed numbers. That was a mixed number and an integer, which is great. The fact that you're coming up with these problems are great. Does anybody at this table have one with 2 mixed numbers?
Yeah.
What is it, Daniel?
Okay, what, the problem?
Yeah, what's the problem that you had with the real world example? And then we'll solve that one as a class.
Anthony bought 1 3/4 of it.
Make it 2 and 3. So
2 3/4 of
So Anthony bought 2 3/4
pounds of candy.
pounds of candy.
And he ate 1 1/3 of it. How much is left in the bag?
And he ate 1 1/3 of it. How much is left in the bag? So he had, what were our numbers again?
2 3/4.
So he had a period there. He had 2 3/4 bags of candy. He had his period in that sentence, not that. But there was a period in that sentence. Then he had 1 1/3 that he ate. If he ate that, are we going to be dividing or are we going to be multiplying? What do we think? Miles? Dividing. Exactly. So we follow those same steps with our real world problems, with our nice pieces of candy. So make sure that you've solved either one of the word problems on this page. If you've already solved one of those word problems, I want you to solve this one. Okay? I'm going to call on one person. You tell me what you're doing, why you're doing it, and what you are doing, like what you did. Okay, Lucy, what's the first thing? What do we do? So first we turn it into an improper fraction. Why? Because if we didn't, we wouldn't be able to multiply. Exactly. We get 11/4. I'm just doing it fast because it's more important to know the steps, right? So, now, what do we do? Who can tell me the next step? What do we do? Fernando. We make 1 1/3 into a mixed number. Same reason, because we can't do it otherwise, right? So we make that 4/3. And then I just multiply them, right? No, what do I got to do?
You need to cross cancel, and you have to do it because
Do I cross cancel? Let's see. He says we cross cancel. Put your thumbs up if you agree that we cross cancel right now. Thumbs up? No. What do we do? Madison. We do the reciprocal because when you change it, then the sign changes. Exactly. What's the reciprocal of 4/3? We get, yes, 3/4. Go back to your seat, but don't start packing up yet. And then that change, it becomes multiple. Oops, I know, I did the same thing. My bad. Yes. Hold on, I don't want to hear chairs. So, we get 33/16. Is there any way we can simplify that? Lucy? Exactly, it would be 2 1/16. She said that we made it into our mixed number. The first question was asking is, could we simplify the 33/16 anymore, like divide it? No. So here's what your homework is. Your homework is going to be page 329. 329. What I want you to do is I want you to do problems 1 through 7. That's the full front page and this entire back section of the back page to make sure you understand what you're doing. Thank you.